Okay, so we're going to move to the finishing cut. Before we get to that, some CAM packages will allow you to reuse the geometry from the roughing cut as the stock for the next cut, so that it already knows what's been cut away, so it doesn't waste time cutting it. Now, this feature may exist somewhere in DeskProto. I'm not 100% sure. If it does, I can't find it. But how you would get to that in general CAM packages is you'd run your simulation. So where is my sim? Alright, let's calculate it, and then we're gonna hide the toolpath here so we can see what we're doing. So I've right clicked the screen and I'm going to turn off the toolpath for now, just so we can see. Now that's the roughing operation. That's what you expect to see on the milling machine after this path is finished cutting. So we've left a 0.3 mm skin everywhere, and that's going to allow us to come in with the small cutter faster. Now, generally speaking, and I'll speak to Lex about this, you can use this as stock for the finishing pass so that it doesn't waste time cutting air coming down to the part, especially important when you're in steel. For now, we're not too stressed about that, so I'm going to hide that and turn back on the toolpath. Now, we've already saved out the toolpath in a previous video. What I do is you can put your finishing pass inside here. Because I'm prone to doing copy paste, copy paste, copy paste, and apply the changes across an entire tool chain, I'm also very prone to forgetting that I've got stock in my roughing pass, and then I apply that to a tool chain, and then I cut a finishing pass with stock. So what I'm going to do now is not generally how you would do it, it's just something I've learned to do the way I work. So we're going to file and save this project as, and we're going to go into the cutting demo, and I'm going to call it roughing. Alright, whoops. And then we're going to save it again. So I'm going to save it once, and then I'm going to save as finishing. Now I'm going to use a 0.5 mm tapered ball end and save it out like that, so that I don't overwrite the original file. I don't want to lose what I've done. Now this saves us a bit of time because we've already got everything inside there. All we've got to do is change that pass. So I'm going to go in here, I'm going to rename that. Tapered ball end. And I'm going to call it finishing. Whoopsie. And all I'm going to do now is edit this to say that I'm no longer working with that tool. I'm now working with this tool, which is the tapered ball nose, 0.5 mm diameter. Alright. I'm going to bring my cutting distance right in because we want a nice clean finish on this. So I'm going to bring it into, say, 30 micron, 60 micron. Let's have a look. Let's cut like this and run a simulation and see if it's tight enough, and if not, we'll come back and drop it down a little. Alright, so we're good over there. I'm going to use the same strategy as last time, and again along the axis. Now you've got to be careful in roughing. I'm going to take that back down to 0. I'm going to cut right down to the bone this time, and I don't need to do step downs over here, but I think it's going to take way too long, so I'm going to just leave that on. Use cutting length of cutter. Area remains the same, nothing's changed. Nothing's changed there, nothing's changed there, and we can apply and click OK. So this is now going to do the finishing pass for us, right down to the bone of the model, and we're going to simulate it and see if it got in close enough, or if we liked how it got in. Now you note that I still left that on 400 mm a minute. I'm going to dynamically, in the next video when we're in Mac, change my feed rate until it looks like I'm not burning the wood or I'm not putting strain on the cutter. That's a completely different video. Now, the problem with when you're cutting wood is there can be knots in the wood, there can be all kinds of things going on that change how you want to do it. Let's close that. And you'll have a look now that you've got the same thing going on. It's just going on a lot finer, and it's right down to the bone of the model. Okay, so I'm going to have a look at the simulation for that. Let's calculate it out. And let's hide the toolpath. And also let's hide the model. Where is my model? Geometry. There it is. Okay. And you can see here the step over is causing some granular lines along here. You can see a bit of striping. So probably that could have done it being a little bit finer. However, I'm going to say that the simulation is mesh based, and I doubt that those lines are actually going to show up in the model. But it's a good indication to see whether you achieved enough resolution on the part or not. I'm going to go with, I think, 50 micron. I'm going to take that 60 micron down to 50 and see how we go. Now, the second reason I save these things separately is if I've made a boo-boo and I want to repath it a little bit finer, I actually leave the stock in the machine after examining it, come in, recalculate these parts, and maybe cut a second pass before you move the part. After you move the part, you're pretty much screwed. Okay. Alright, I'm going to turn my part back on and my tool paths, and I'm going to go in and edit that and probably cut a little bit faster. Now, as you can see, that you were seeing striping in the simulation. Within the real world, that striping doesn't exist. I would say that that's just because that's a mesh model. Alright, that's actually looking really smooth. The transitions are looking smooth. I don't see anything awkward happening over there. I am, however, going to go in and cut it a little bit closer. Um, 50, 30. You can pick what's in there, or you can put in what you want. And let it recalculate. And then we're going to save this path out. It'll take a little bit longer to calculate now because it's tighter. It's twice as tight as it was, so it should take twice as long to calculate. But it's also twice the definition it was. Now, if that looks boring, trust me, this is fast. Doing the same thing in RhinoCam, after 7 hours I had to shut RhinoCam down. It just wasn't finishing the path. So we will do a second video on RhinoCam. Give me a minute to talk about that while I'm in here. The advantage of RhinoCam over DeskProto would be the fact that it runs in Rhino, so you can directly use your curves inside a Rhino. You can select part of the models the way that you're used to working inside a Rhino. There is a plugin that was used by the GemVision boys, which was a very good implementation of DeskProto inside a Rhino, and hopefully at some point down the track Lex will get to offering that inside of Rhino, or an API for allowing us to connect it into Rhino. Excuse me, interim. Let's let that path finish. It usually gets up to like 60%, then suddenly goes finished. I'm going to pause the video while that's happening. Okay, so that was about a minute, and we're done. Now, there is a factor inside of DeskProto that calculates the theoretical machining time and the actual machining time based on the speeds that you selected, and also a machine multiplication factor. Now, I have not adjusted that over here, but 100% for sure this is not going to take 16 hours to cut, probably closer to 5 or 6 hours to finish this cut. So I'm going to close that out, but you can use the machine factor inside of DeskProto. If you cut something that it's estimated 8 hours and 23 minutes and you log your actual time it took to cut, you can go change that factor to start giving you some accurate real machining time. You can see my factor is ×2 at the moment. I would estimate it's closer to 0.8, 0.7, somewhere around there. Alright, so we got that path. It's now twice as close as it was, meaning that we've got a much finer path to cut through. Alright, we're going to save that out. And just examine the file. Open that up and have a look at the file. Oopsie, wrong video. Unfold it. Now on large paths like these, you'll see that that's clocking in at 23 megs. Regular Notepad will fail on you. You'll have issues. It'll be very slow and laggy. That's why I recommend you get a Notepad++. So pretty much everything looks okay over here. For the finishing pass, I'm going to manually in Mac, I'm going to adjust that up or down depending on the sound the machine makes. Alright. Otherwise, pretty much everything looking alright. So we can close that out. And the next video is going to be me setting up Mac and the machine and then actually cutting this part. So let's save that project out. So we've got 2 projects in the folder, one for roughing, one for finishing, and we're ready to go machine.